So this is number 5 in your review, Rhonda, where you're told that the diameter of a certain species of trees has a normal distribution with a mean of 20 centimeters and a standard deviation of 2 centimeters. A random sample of 5 trees was collected from a very large plantation of such trees, and their diameters were measured. What is the probability that the 5 trees selected will have diameters between 18 and 23 centimeters? Notice that on this one, unlike the one we did together today, they're not asking you to find the probability that the average will be between that, but just that a tree's diameter will be between 18 and 23 centimeters. So the first thing I'd recommend you do is just sort of picture this problem that we're dealing with. We've got a normal distribution, we've got a mean of 20 and a standard deviation of 2. So this would be an 18-inch diameter tree, a 16-inch diameter tree, and so on. If I go out one standard deviation above the mean, this would be a 22-inch diameter tree, a 24-inch diameter tree, and so on. And we're looking for trees to have a diameter between 18 and 23. So we're really looking for this proportion in between here in the normal curve. So we're going to have to do something similar to what we did today, except that this isn't about a mean, it's about an individual tree. So we're going to find our z-score for randomly picking an individual tree with a diameter between 18 and 23 inches. So our first z, we'll use the lower diameter. The mean given was 20. The standard deviation was 2. So we can see that that first tree is 1 standard deviation below the mean. Our second tree of 23-inch diameter would be 23 minus the mean over the standard deviation. And we get 3/2 or 1.5. So with the help of our normal dist command in Microsoft Excel, say our normal sdist, we'll give our z-score, I'll do the first one, of -1. And cumulative, yes, we want the less than or equal to. So we'll say 1 for yes. And it gives us an area below that of 0.1587. We're going to do the same thing with our other z-score of positive 1.5 and say yes to cumulative again. And that gives us 0.9332. And then anytime we want the area in between, we just subtract those two, bigger minus smaller, and we get 12 minus, okay. We get an area of 0.7745-ish for an individual tree to have a diameter between 18 and 23 inches. We want all 5 trees in the sample to have that diameter. So we're going to need to take that 0.7745 and multiply it by itself 5 times, or, in other words, raise it to the 5th power. And so we find the probability that all 5 trees will have diameters between 18 and 23 is equal to about, depending upon how you rounded, 0.2787. So now notice the difference in question B. It's saying what is the probability that 5 trees will have an average diameter of between 18 and 23 centimeters. So what we have to do differently is we have to use our z-score for the average formula that we used in our example today. So our x-bar that we want, our lower x-bar is 18. Our mu is still 20. But our standard deviation is going to be what we get when we divide sigma 2 by root 5. And that's about 0.8944. When we calculate that z-score by dividing the -2 on top by the 0.8944, we see that it has a z-score of about -2.24. If we do the same thing with the upper end of that interval for our average, 23 instead of 18, our second z-score is going to be what we get when we divide 23 minus 20, or 3, by our standard deviation of 2 over root n, or our standard deviation of 0.8944. Square which is again our 2 over square root 5. And for our upper z-score, we get 3.35-ish. Then we can use Microsoft Excel, and we can choose normal.s.dist to get the area below a z-score of -2.24. And we get an area below the -2.24 of 0.01255. And then we'll have to do the same thing for our bigger z-score of 3.35. And we get an area below for the blue z-score of 0.9996. And then, as always, whenever we want the area between, we take bigger minus smaller. And depending upon how we rounded, we get an area between equal to about 0.9869. Now C asks us, your answer in part B should be larger than your answer in part A. Explain why this is so. The reason is because you're in a distribution that is narrower. It's not as spread out. And therefore, you find that you have a larger proportion that are between 18 and 23 than you did when you were just finding an individual tree whose diameter would be between 18 and 23.